It involves transforming raw data into a format that is more suitable for our analysis. And you can think of it as like data cleaning stage in Pandas, but this time it's not for a CSV file, it's for a machine learning model. In today's episode, we're going to jump deep into the ins and outs of data pre-processing, highlighting its significance, methods, and best practices. Welcome back, guys, to another episode of PyPod Chronicles.
Welcome to PyPod Chronicles, a series that brings our tech blog to life in a whole new way. Covering an array of topics surrounding Python and tech, from programming tips, best practices, and so much more. Let's get immersed in Python with the Nerd Nook on the go.
Welcome back, guys. Before I dive in for another episode here of PyPod, right, you can get my handcrafted Python and Get Starter Pack. It's absolutely free, guys. It's the link in the description. And the link in the description is so much more than just that starter pack, right? It's everything that I have created, right? It's the blog. It's all my advanced things, right? So head on down there, take a look, and get a copy of that while you're at it. Now, all right, I mentioned today's episode, it's data pre-processing. Think of this as like data cleaning, right? Now, this plays a pivotal role in ensuring the success of our machine learning models. This key step allows for our models to get the best chance possible at the most accurate predictions, right? And here's my few reasonings behind this. So data quality, right? A lot of raw data, it contains inconsistencies, errors, and oftentimes missing values. So pre-processing helps us in identifying and rectifying these issues, ensuring that our model has the most accurate and reliable data. That means we're giving our model the best chance at success. So really, pre-processing just means to clean before processing. Okay, now you should have already done this. If you're going through my entire series, I started on day one with Pandas in just introducing data, cleaning data. And we do clean data in Pandas, but now we also need to re-clean the data, okay, pre-process it for our machine learning model. That's what we're doing here. Another reasoning behind this is feature scaling. Now, different features in the data set may have varying scales. So pre-processing techniques like normalization or standardization, they help in bringing all these features to a common scale. And this prevents any bias down the road with our model training process. And the more bias that we can remove from our data, the more accurate these predictions, right? And you can see that I'm circling back to these predictions. Another key point, right, is dimensionality reduction. So high dimensional data, right, think of one-dimensional. Two-dimensional is like a spreadsheet, right? So working with spreadsheets or more, high dimensional data can be computationally expensive and may lead to overfitting. So techniques like PCA, right, principal component analysis, can be employed during pre-processing to reduce these dimensionalities without any major loss of our information. Okay, so you heard a lot, blah, 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 I get it. Let's talk about the steps now in data pre-process. It involves several steps to transform this raw data into a format that's ready for our machine learning model to accept. The first thing we want to address and handle is missing data. So we need to ask ourselves, do we have any missing values? Begin by identifying the presence of missing values in your data set. And this can be achieved by functions like isNil, right? So a few episodes ago, go back to the Pandas episodes where I talked about cleaning our data, okay, data cleaning. This is the same type of process, and it should have been done at the stage. Once you've identified any missing values, then we can implement our imputation techniques. So, do you have missing values? No? Skip this. Yes? Okay. What do we want to replace these missing values with? An often value is the mean or median of the whole series of data. So I can get the average, right? If you just want to drop it completely, that's fine too, okay? But it does depend on what data you're trying to answer. Sometimes we want to replace the data with an average, is a great example. Other times you want to replace the data with 0. And other times you just want to remove the data altogether. That is up to you. Let's talk about a few advanced techniques now. So the first one I'll talk about is forward and backward fill. And this really comes into play with time series data, because missing values can be filled using the previous or subsequent value. So, as an example, right, if there is a missing value at a specific time point, forward fill would replace it with the value from the previous time point. And backward fill, well, that would work like this, but vice versa. All right, so forward, backward fill. We also have K and N. Now, I'm going to talk about this in the coming episodes, but K nearest neighbor, that imputation. And this method involves estimating missing values based on the values of the nearest data points. So imagine you're a data point, and I collect the 10 different points around me from the 10 nearest data points, and those are my nearest neighbors. And I just use the average of all of those. Now, this is applicable to both numerical and categorical data, making it versatile for different types of data sets. And we're going to check this out in coming articles. Okay, KNN, K nearest neighbor, if you want to look into that now, you can. All right, let's slightly move into another topic here. Okay, I'm covering a lot. But encoding categorical variable. We have label encoding, one-hot encoding, and ordinal encoding. Now, label encoding involves assigning a unique integer to each category within a categorical variable. But just use caution, because this method may introduce ordinality where none actually exists. Okay? One-hot coding creates dummy variables for each category within the categorical variable, converting them into binary. This eliminates the ordinality issue I just mentioned with label encoding, but it can increase the dimensionality of the dataset. Right? Now, remember, slow down, because dimensionality, we're trying to avoid that. And if you have a lot of this, we talked about concepts like principal component analysis, PCA. And finally, ordinal encoding is just with natural number order, low, medium, high, ABC. Okay? It just goes in order, preserving the relationship between categories. All right, what do you guys think so far? That's a lot of new information that we're covering. Now, the last real one I want to talk about, all right, is feature scaling. Okay? And I'm just going to touch on this here, 60 seconds, okay? Feature scaling. We have normalization. Normalization scales features to a specific range, typically between 0 and 1, using a formula. Okay? I can't say the formula here because, well, you're not going to understand. And the other one is standardization. Now, this transforms features to have a mean of 0 and a standard deviation of 1. The general method of calculation is to determine the distribution mean and the standard deviation for each feature. So you've pre-processed your data, you've cleaned your data. It's now time to split your data, to train your data, okay? And I actually have an article out already about this. Head over to the link in the description, Train, Test, Split, right? This will be an episode in the coming weeks, but we need to talk about this because now it's time to split that data after you've pre-processed it. I'm only going to touch on it here because that's coming for us very soon. Apart from the commonly used training and test sets, consider splitting the data set into training, validation, and test sets. The validation set actually helps in tuning hyperparameters and preventing overfitting. We're going to introduce this at a later stage, so don't worry. And this is also a key concept in scikit-learn, so it's going to be essential once we start programming. Now, for data pre-processing with scikit-learn, you can use the pre-processing module. More specifically, there is a class called standard scaler. This takes care of the pre-processing for us. Now, some of the best practices for data pre-processing is we need to maintain data integrity. So always keep a backup of the original data set before you apply any of these techniques. And explore data, right? Gain insights into the data set by performing EDA, exploratory data analysis, before pre-processing. This is going to help you understand the underlying patterns and relationships within that data. Another key detail is the iterative process. Now, data pre-processing is often an iterative process. Regularly evaluate the model's performance after pre-processing to identify areas that you can improve on. Let's wrap up this episode of pre-processing. This was the second one in my machine learning series. If you guys want to head back, explore machine learning or data analysis, head over to the blog. It's the link in the description. I break it all down for you guys. And I'm not done there. I'm going to go back, make more articles, more episodes down the line. To wrap things up, there you guys have it. Data preprocessing is a critical phase in machine learning workflow that demands careful consideration and implementation of various techniques. By carefully handling your missing data or values, encoding categorical variables, scaling features appropriately, and strategically splitting your dataset, you can enhance the performance and readability of your machine learning models. Now, machine learning is such a large topic. That's why these last 2 episodes have been focused on breaking down the logic and terminology behind machine learning before introducing anything too overwhelming. That's what we're going to be looking at in the coming episodes. This will inevitably help you with the learning process and give you more time to grasp concepts further down the line. Well, guys, there you have it. That is another episode of PyPod Chronicles in the books. I will see you guys in next week's episode of PyPod Chronicles. Until then.